Thank you, everyone. Hello. Good to be back. We were here last year, for those of you who were here then. We launched our software company startup. Then you met myself and my CTO, Benza. Today we're here with 10 employees, so I'm happy to report we're still alive. We managed to get a couple of customers and partners. And really, it's an extension of last year's project and presentation where I want to talk about the impressions of the first year on the market, where we see the enablers for circularity, and what we think is needed to be done. So the main message is being, to give you last page first, it's easier to connect data than humans, even though if you have good processes and software. I won't talk a lot about software because it's a very easy world. You can more or less do anything with software. It's more about the process and the disciplines. Then I would like to highlight the importance of the impact of the vehicle, which is the powertrain, where we have the most materials, we have the most rare earths, and we have the most USPs driving the product. And thirdly, I would like to take those insights and talk about what will happen when the shift to product as a service comes. When the OEM becomes a fleet, what happens to aftermarket value that suddenly may become a cost point instead of a profitable point? And how can we use that at the early design stage? So this is what we'll try to do today. As I mentioned, we're a small and agile tech startup. We are purposely driven by engineering. So we have engineering partners, engineering owners who want to sell consulting projects, but the customer said, can we just have your software instead of the consultancy projects, please? So we can run our own studies and learn our own insights because data is constantly changing. And we come from automotive powertrain. Product's been around for 5 years, but we more and more see adoption outside automotive, energy transformation, aerospace, commercial vehicles, going beyond automotive because it's basically the same powertrain, which is transitioning energy. So why are we unique? We have a speed versus fidelity philosophy, which we're very focused around, and it's a very cared topic to maintain speed versus fidelity. It can sometimes mean saying no to customers. It sometimes means a lot of explaining why is it important. The important thing, what I want to tell you today is the number of options you can play through, as you see here on the right side. How do I design my car? How do I design my powertrain? How do I bring in new materials? How can I reduce mass? If it costs me 2-3 months to play through 3-4 ideas, I'm not going to be radical in my approach and use brute force on the software. We need less details and enough details and high speed. So overnight, 50 motor platform concepts overnight, for example. This will allow the engineer to be exploratory, and it will allow new vendors to come in who have more sustainable materials to offer. So this one we showed last year as well. My main message is the powertrain system optimization is a circularity enabler. Why? Because everything is determined at the design stage, not later. You can incrementally improve your design or your product after it's been launched or even during development, but it's in the earliest design stage, when the whiteboard is still white, that you determine circularity. The dark blue spots are the areas we've addressed in the past years, from design, from adding different components together, different batteries. The use case represented by WLTP or US06 or other drive cycles or aerospace drive cycles. What we're working on today with a major UK OEM, for example, is all the other 4 bits, which will enable the toolset to simulate full cradle-to-cradle product development. So that includes what is the production process, what is the transport and distribution, considering CBAM coming in, what happens at end of life. I somewhat agree to my previous speaker from Lotus that yes, it's the driver owning the car, but I see more and more companies going into product as a service, even in automotive, so they need to worry about what happens at the end of the life. Plus, where do you draw the line to raw materials if you recycle? So, highly illustrative image from my learnings from the last year. What is out there? We've been talking to OEMs, tier 1, tier 2s, and tier 3 and upwards, so materials and processes. And in my mind, there is three levels of, or several levels of how circular or sustainable are you. Basically, everyone has a sustainability report, backward looking, what is the impact we've done. Then there are some players who have committed to voluntary initiatives, science-based targets and others. And then there is a perceived idea of we're fully circular, but there are also some players out there like recyclability companies who actually have an embryo for full circularity. So as I mentioned, this is more or less the baseline. Maybe you have some tier 1, tier 2s who understand and are further on the initiative side, and you really lack the further away you come from the raw material, the impact of circular design. And I think usually powertrain engineers, at least the ones I know, they're really good at engineering powertrains. So they don't really have as a focus area to worry about sustainability. The sustainability experts I met are realistic. They know what the challenge is, so they're not blowing up the balloon and trying to oversell something they know isn't achievable in the next 5, 10, 20 years. And then there's this external perception, which, oh, we have a circular idea, so now the whole company is circular. It's very much not the case. It happens very often. And it's about having a scalable approach to enabling circularity. And one thing I will talk about more is number of suppliers. So I think the further away you are from the raw material, the more difficult it is. So obviously it's highly complex to put together a vehicle. And it's even more complex to put together a BEV. Yes, it's less parts, but it's all new parts. It's new territory, new processes. So let's look at how complex it is to build a car today. First off, as I mentioned, the organizations, the most difficult bit to enable decision makers to look at the full picture. Yes, the car needs to drive. There's a wheel torque requirement. There's a speed and range, but there's also an LCA requirement. There is a profitability requirement that needs to come into play into the right decision rooms. There's basically more than 3,000 parts in a BEV, all materials on the planet, more than 400 polymer grades. You have, for every OEM, probably 10 to the power of 6 of sub-suppliers and more than 100 different geographies. So it's an extremely complex environment to navigate. You have KPIs, which will be unique. We discussed KPIs before. I talked to another British sports car maker who are the head of the team who develops their first electric car. And they were really frustrated because they said, everyone can have a car 0 to 60 in under 3 seconds. And who are we if we're not loud and fast anymore? Everybody has that. So the USP is reduced to stuff like interior, maybe NVH, noise vibration harnesses, range definitely is out there, but it's about finding that USP beyond acceleration and noise, which isn't around anymore. And then in the automotive industry, yes, we have 10% impact on the world, but we have an extremely long development time. So the cars that aren't sustainable or have alternative materials in today will live beyond 2060 and onwards. And I don't personally, from the first year, feel that sense of urgency really in any of the conversations we've been having, and we've been quite busy. So there is definitely need for more action. So let's look at the powertrain. Why do we care so much for the powertrain? If we think about the rare earth materials, so cobalt, neodymium, electronics, this one really astonished me that it takes 1,500 tons to make 1 ton of cobalt. Yes, there is only like 40, 50 kilo in the battery, but it's a massive amount of waste that you're creating. And it all sits in the powertrain, mainly in the battery, but also you have rare earths in electric machines and electronics. And you have the EDU value of a car, which is the largest part of the car. So this is why ZeBeyond really focuses on the powertrain. So we believe that has the biggest impact on our platforms in our cars and on circularity. So this presentation is really going to be about talking about powertrain and shedding some light on that more than selling our software, really, because we think it's important to wake up to the system powertrain perspective. So we believe that today we're still building on traditional powertrain optimization as it was done in the ICE world, but nobody really bought a car because it has a certain size of fuel tank, which we do today because of the battery, because it weighs almost 2 tons and has a huge impact. We believe after that there is more maximized approach for recyclable and renewable materials, improve lifetime on the back of product as a service, and probably on the back of 2035 we'll start to see real high-tech, low-weight and highly recyclable materials. And these are cars built in 2035, which means we're up way beyond 2030 of an 2060 of an impact. The answer to looking at the materials I showed you in the powertrain is really going from an approach where you have to sieve through the tier levels to creating or enabling intimacy between OEMs and material suppliers. I don't believe this picture should say cut out all the middlemen or do the same with less. No, it's about preserving the competence in the supply chain, but having an intelligent conversation with a proper tool set and collaboration at the end to ends. It also shows that we have to remain experts in the fields we are, and we have to collaborate more. So you got the question if there's one software, and there isn't, and ZeBeyond and ePOP isn't that software, but collaboration of people and software is definitely the answer. I don't think there's a one size fits all. So what do we do about this more circular approach? So what we do is multidimensional and iterative optimization. Multi-dimensions means you have a set of requirements. In the engineering world, it's very easily reduced to numbers. Numbers is speed, range, acceleration, wheel torque, CO2 emission. It gets harder when we simulate for something like toxicity. It still works, but really hard when you optimize your powertrain for means of disassembly or use of water, because it isn't as easy measured as CO2 equivalent per ton. So we bring together engineering, finance, and sustainability, and then we have levers beyond that. And at the end, we have the materials. This is how the software is built up. The input data you provide can come from, or usually always comes from, application. So what is the car? How is it represented in the software world? Weight, what does it need to do? Which components do you want to equip it with? What is the speed, the gradient, and so on. Then we offer a growing library of components. This means induction machines, axial flux motors, set of inverters, batteries, or customer data, or third-party data. And then we have a bunch of interfaces, which is continuously growing. We started out with MotoCAD, JMag, but also now we're working on plugins, for example, to EcoInvent or customer in-house software. So we're really trying to bring the pieces together from the best of breed tool sets in this detailed design to have a wider vision on what is the overall circularity impact. What you get out of the sausage maker is basically, what is my drive cycle performance based on the components I equipped the car with and the detailed design ideas I had? What are the energy efficiencies? What is the LCA going into the design stage? Not looking backward, what is it on our existing cars? Considering new batteries, recycled batteries, what will be the LCA number we're looking at? Or taking it even one step further, we have a next platform. This is the LCA number you need to achieve, nothing else. You can immediately constrain your design study from day one. And you don't need to have the discussion at the end when you only have two options left. Do we go profitable or sustainable? There are a million grades between that. It's important to constrain the project right from the start. Or not, up to the user. Increasing impact we see with one partnership I'm happy with from Sweden, product lifecycle optimization, looking at plugins from bill of materials through Windchill to enable product lifecycle material at the early design stage. So how long does this rubber or this screw or this motor live? Let's consider that when we build the next car. So how does it work? We build up a vehicle with unique products. We represent it on a system level, and we quantify it on a platform. So for example, you would take a VW ID4 as a benchmark, which is a benchmark vehicle. Any other vehicle is possible. You have invented a green steel, and you want to understand what does it do to my car. We basically take you through this forest, which is complex, highly complex system engineering. We add drive cycles, we add LCA data, and you come out with saying, okay, here's the benchmark, and here's my alternative product with my alternative material. What this means is usually a recycled battery, for example, or any other component that has a sustainability pitch is more expensive than the state of the art. That also means you probably or not can downsize neighboring subsystems. For example, if you have a more efficient motor, if you have more efficient electronics, you can downsize the battery. But since the conversation of selling a motor or an electronic isn't happening on a system level, the benefit on the vehicle is not seen. So to enable more expensive, looking at only one discipline materials, you need to look at the full system and see what does it do to the whole car? What does it do to the mass? How much less cobalt do I need if I buy this chip? And it's about quantifying that data. And it's about changing the drive cycle quickly. It's about changing subcomponents quickly, or changing the application as a whole. So, iceberg. This is a quick trip into powertrain engineering and system level optimization. What we think a system might be is speed, range, cost, acceleration, but there are many more disciplines below that. So what I learned in the past year is we ask our experts to optimize e-machines or electronics. They go deeper and deeper and deeper into magnets, thermal dependencies, and at the end of the day, they don't even know what they're working with from a system perspective, and more or less left alone in sub-optimizing the subcomponent. It's not enough with that you then need to get e-motor experts talking to electronic experts, with transmission experts, and now new to the party, battery materials. And it doesn't stop there, because if you go deep into e-machines, you have magnets, you have eMag. If you go deep into electronics, you have hardware, software, which is different PhDs, different careers, they don't even have the same software to talk to each other. Sinter or solder, my hardware, different disciplines. Lubricants, totally different sector again. And battery, probably the biggest unknown under the surface. What impact does my different anode cathode combination have on my e-machine or my electronic? So then you have these dependencies between, represented by these fish. For example, thermals. You mentioned cooling is really important. So how do you make the systems operate at exactly the right temperature in order to increase efficiency, to increase range, reduce batteries, reduce materials? What if I increase voltage? What if I want less noise? It's all a system question. And at the end of the day, what ZeBeyond really excels at is the physical limitations. So our algorithms are not about give me the best motor, it's 100% efficient, which can't be built. The trick is with the right speed and fidelity, to have full factorial algorithms constrained by the physical viable. And now we haven't even started discussing KPIs. So if you then test this system against your targets for management, this tide will start to flow around, systems will start to move, assumptions will change. So our vision is really to unlock circularity, to bringing these circles together, and maybe we can find an optimum system for off-highway heavy duty, A to D segment, and smaller applications, for example, or other allocations. But currently, we're not seeing any streamlining across this process, which has the biggest impact on the vehicle. So if we remain with this, what ePOP then does is, if you're a material technology or process supplier, it can take you through the system level and represent your material on the end user application. As an OEM or system integrator, which also can be a tier 1, tier 2 today, building an inverter or different components, this means you can screen the library for new materials directly from the system point, not looking, I want a better motor or inverter. No, you're at the end user application. And if you're a sub-supplier trying to shout through this forest of suppliers, you can actually quantify the vehicle level impact of your materials directly in your sales meeting. And why do I say sales meeting? Because another thing I learned in the past years, it's much harder to convince an engineer rather than a salesperson. So if we want to enable circularity, it's enabling those who really are better at talking. And I think if you approach an engineer, we will be very happy once you have, transformed the message. You have convinced, no, we're not here to compete with your existing process. This will actually improve your way of working. I believe it will be faster for circularity if we make circularity a commercial viable product. This means enabling people who have more sustainable products, taking them through this forest. We have 25 major platforms across the supply chain that we've achieved in the past 5 years. ZeBeyond was founded 1 year ago, transitioned into a dedicated software company. We see a lot of parallels between different sectors, and we see a lot of parallels between different levels of the supply chain. So I don't know how I'm doing on time, but just wanted to give you the importance of quantifiable impact. If you take a small OEM, which is, for example, Polestar, who still call itself a startup, 100,000 cars a year, and you want to optimize performance, cost, and sustainability. What does it mean? You can take 1 kilo out of the car, just 1 kilo out of the battery, and you would save a couple of thousand megawatt less energy. 50 euros is a lot of cost reduction on an annual saving of 5 million. And 10 kilos of CO2 would be a couple of thousand CO2s over the lifetime. Depending on which OEM, very different, but you have a huge impact on this today's platform development. And it's really all about that 5% last of optimization. So this is what we face talking in the engineering room. If you come with a totally new battery, you're really annoying because then I have to redo the 95% and build up my whole system again from beginning. I don't want to do that. So this is what we try to do with ePOP. You can stay optimizing the last 5% and still have radically new ideas. So 3 use cases: gearbox, 1-speed, 2-speed. Motors are very efficient machines, but to align with different targets such as gradability, acceleration, high speed, sometimes it's better to add 2 gears or more, or 2 speeds. So what we did with this customer is embed that different gearbox designs into ePOP and let the customer screen for how many speeds do I need, which gear ratios are best for which motor. Because we have 3 motor RFQs lined up here, and we need to match it with inverter and transmissions. What we did with another partner, Aganas, can even mention that, is what would it mean for a benchmark vehicle to run on recycled soft magnetic component powders instead of laminated steel sheets? And can we even achieve the same range, speed, and cost? We don't provide the answer, we provide the tool set. So this means going from Höganäs, who probably is a tier 8, very high up the supply chain, directly down to the use case and representing that material in a user interface. And last but not least, probably many have heard of it, state-of-the-art IGBT inverters who are used in most platform scales. Tesla has been chosen above silicon carbide, who is about $20 more expensive, but means you can downsize your battery. So on a system level, it's actually cheaper. So if you're an inverter salesperson and you try to sell your more expensive inverter, you actually can justify that increased cost because you downsize or decrease the cost of the full vehicle. Yeah, and that's it. We believe that in 10, 15 years, OEMs will continue to become the fleet. There will be more and more consolidation, which means we have a couple of modules that you see here, but I believe the biggest game changer, my own opinion, will be durability and lifetime, because it will mean changing the mindset from making money in the aftermarket to spare parts and service becoming a cost item instead of a profit center. This you can take advantage of in the design stage. Key takeaways: data complexity is still there, especially for BEV, the second generation's BEV coming out. It's even more difficult to bring people together, so collaboration, than it is to bring data. Collaboration across the supply chain should happen more openly. It shouldn't mean threatening the supply chain in between. And late to the game will, of course, be down selected from investors, regulators, and customers. Thank you.
Do we have any questions for Wiktor?
Good. Thank you very much.
Just really quick, you had mentioned an organization, an overarching organization on one of the slides. Are there any suggestions or thoughts from your experience in terms of who then is that overarching organization?
I don't recall mentioning an overarching organization. I mentioned an overarching collaboration across the supply chain, but I didn't mention one organization taking it all, basically. Maybe that was not clear.
I think maybe, let me rephrase my question. In a circular economy, in a circularity strategy, who is the ultimate decision maker if you have engineering, sustainability, and finance sitting at the table?
I mean, ultimately, it's the investor. If he or she is aware of all the consequences, which he usually or she isn't, I wouldn't say it's legislation to point the finger there. I would definitely say it's getting the right information out of the R&D room into the boardroom through an easy tool set to get all the information right. Because currently, at least the investors I meet, and I've met a lot in my past career, absolutely no know-how in the decision stage of the actual trade-offs in the technology. And I don't believe we lack technology. Technology is there. It's that those decisions are mainly based on trust. Do I trust my head of R&D? Do I trust my product manager? Yes or no? It's not, have you understood the complexity for your wheel torque if you choose recycled batteries or not recycled batteries? And what does that do to my profit? So it's uncertainty which leads to trust and politics inside organizations instead of fact-based decision-making. My opinion.
Thank you.
Thank you. This is Jon from Curare. It goes in the same direction a little bit. So the examples you showed, where you have these examples where materials and tiers and the OEMs apparently work together already, or how did you got all the data to include in the system?
Yeah,
did you have to use all tiers, or are there some assumptions within these
Yeah, some are assumptions. Most of our data is based on validated models, which have actually been on a dyno test track. But we have three methods of getting data in. One is the one I showed through plugins, through detailed design data. One is simple Excel spreadsheet where you can say, these are the performance metrics of my product. And the third one is the drive cycle. So the three ingredients you need for the cake is the application, the components, and the use case. So yeah, it's Excel import, plugins, APIs, or new creation of components even. I understand it's a lot of work to build up a whole powertrain in a software study, but we pick up components through each project we do, so we have a growing library approach. So if you do a project, for example, we have a library of 10, 15 different inverter suppliers, 2, 3, 4 different motor topologies, seed motors, and so on. So we build up this library together. Yeah. Did that answer the question?
Yes, I think so. Thank you.
Good morning, Matej from Prague. In these discussions that you see in the sector, did you experience the focus also on clean energy, clean electricity? Is it important for these discussions, or it's not considered at this moment? Thank you.
Yeah, it isn't considered in the engineering room, but we have had the opportunity to go across the engineering room to the sustainability room with more than one OEM, and there it's very much considered, but very much detached from the design questions that happen at the product development, which again leads me back to, yes, it is, but the human aspect doesn't work because you are tasked to become more expert in your discipline rather than go across. And I believe still the engineering room is stronger than the sustainability room, and that needs to change through collaboration. So, for example, that question comes up when we look at footprint location and manufacturability of new motor concepts, for example. Where do I assemble? Where do I source it? And so on. So what are the energy sources at the manufacturing site? Yeah.
Yeah, I also have a question. What do you think would be your best approach from your experience to impact circular design, let's say in the early design stages? Because so would it be a top-down approach, bottom-up approach? Yeah, kick-off meetings just to bring over the concept of circular design to, let's say, the engineers who are, as you mentioned in the last questions, are a better driver or stronger now than the sustainability experts. Because right now we have exactly the problem how to approach this in the whole company, because the focus right now for as a battery manufacturer definitely lies within cost reduction and performance increase and not the sustainability topic. So we try to impact it, but right now we have this challenge.
Yeah, I understand. So there are two approaches. We choose the approach to not work with human change management because it's a snake pit. We try to enable the engineer because we know this is the person who will design the product. So we try to take the perspective of the engineer, and for example, we embed to EcoInvent. That's a database for LCA data. So if you are from, I don't know, Borg Warner, you would be able to screen your system candidate of your transmission, and you would have a number of KPIs of the performance, and you could easily know what is the LCA of my product. The only thing you'd have to know is the amount of iron, steel, copper in your product, the kilos. And then we let you change, for example, is it sourced from Southeast Asia, Western, Eastern Europe, and so on. So we try to enable one discipline at a time. We try to make it as easy as possible in the software world, because we know it's harder for you to walk across the hall to a sustainability person and get them involved, get them understanding in your complex challenges. It's much easier to give you that tool set. Once that has happened, then we can take to the next room, to the sustainability room. So this is the approach, pleasing one discipline at a time. I hope that answered the question.
Yes, I have one, Tiziano Piccardo from Marelli. I was wondering, yeah, it's clear the use of such tools relying on eco-invent, so data sets that are already certified. But when the OEMs are asking us to provide the data regarding our products, our parts, and then part of that should be your primary data.
Yes.
So what happens when you have to deal with the need of primary data rather than relying on existing data sets certified?
It's a good question, and I'm happy to show it in a demo because it actually started out with primary data. So it started out 3 years ago, just replacing cost euros per kilo to CO2 equivalent per kilo in a simple input table in the software, which means you'd have to know the LCA number for your product, primary data. We saw that, like the question here, we saw that that function wasn't very much used because not many people had primary data. But you can always key in your primary data. And for those materials you don't have it, you can switch to secondary data and browse eco-invent library, for example. So there's 3 approaches in our software where we say, first, always primary data, so you can hard key it in, and then you scale it up over the system. You can have a guided approach through the eco-invent database, where we say, you have this gear, a planetary gear, usually that's these 3 metals. Or you can have the third one, browse the full library, which is extremely complex, but if you want to do it, you can do it. So there's the approach to allow both primary and secondary data.
Thank you. But I was mostly wondering on, in your experience, the cases that you've seen, do you really find primary data that you can rely on whenever you do these kind of assessments? Or do you usually go to libraries because they are safer? How do you usually deal with this risk?
Well, the short answer, as a software company, I'm mere the tool, and the entrance of that data is owned by the user, of course. But I will say, because of the weakness of primary data, we looked at embedding with a third-party tool like eco-invent. So yes, there is a weakness in primary data as well. You know, how old is it? Changes in production? Does it accommodate all of? Is it up to date? So I fully agree. That's why we built that plugin, basically. Yeah.
Hello. So there's one more online question from Miss Julia, and the question is: do you have models to calculate the CO2 emission during operation of the car, depending on male age, weight, and lifespan?
Age and weight?
Depending on male age, weight, and lifespan.
Lifespan, but not male and age, right? No?
Yes. Mileage.
Mileage, not male or female in the car.
Oh.
Yes, there is. That's where we use the benchmark vehicle. So we have now, I showed you the ID4, we have a Tesla S, and we're going to import a BYD next. So we take, and then we stick to WLTP, domestic charging points. So we build up this scenario. We have an OEM in a bus OEM who we work with, who even also translating to mining OEM, who is screening for driver profiles. I think this is maybe what the question is about. What is the driver profile? What is the daily profile? Do I oversize my battery because to optimize lifetime of the vehicle, or can I decrease the battery based on charging points on my bus route, for example? So this is an example where we embed the actual use case into the early product design. And coincidentally, in the mining domain, there are different driver profiles for male and female drivers. You can guess which ones are more cost effective.
Thank you.
Yeah. Okay.
Okay,
Thank you.
so that was great, Wiktor. Thank you very much. Give
Thank
a
you.
warm applause, please.
Thank you.